All right, I know a lot of you are planners, so let me just let you know where we're going next week. Today's day 3. That's what your quiz is on, days 1 through 3. Your quiz is on days 1 through 3. Monday, we don't have school, or you guys don't. Tuesday, we're going to come back and do a Delta Math to review for the quiz. And then Wednesday's the quiz on days 1 through 3. All right, so no school Monday. We come back Tuesday together. We'll do a Delta Math that covers everything that's on the quiz. And then Wednesday's the quiz on days 1 through 3. Another corner, please. Not in the same section you did day 1 reviews. New corner here. Please draw circle P. All right, draw me circle P. Good, everyone's got the minute here, a circle with the center at P. All right, let me use some vocab from yesterday now. Please draw me a central angle called APB. Please draw a central angle called APB. Remember what a central angle was. Central angle called APB. That's good. Good job, everybody. Now, can you please put a point C somewhere else on the circle? On the circle, not inside, not outside, on the circle. Just put a point C for me. And now I'm going to tell you angle APB, that central angle you made, is 70 degrees. If it doesn't look like 70, don't worry about it. Nobody cares. Okay, that central angle APB is 70. What I want to know from you is what's the measure? Measure, not the length. What's the measure of arc AB? All right, what's the measure of arc AB? I didn't ask for length, I just want the arc measure. So in degrees here. Alicia? 70. That's the fact I gave you yesterday. Central angle measure is always equal to its arc measure, always. All good? Final thing I need you to do, finish that formula for me. Just write the formula. I'm not asking you to actually find the length of anything. I just want the formula. All good. That's what we should have. So now you have 2 formulas on that sheet that'll be on Wednesday's quiz. And that'll be the last, only 2 formulas you need. We got more facts, but that's it. All good. Okay, save that for Tuesday because that's how I'm going to start Tuesday's class. We got to talk about a different type of angle in the circle. Okay, right away, let's get to it. Put a point C on that circle in the notes, please. Put a point C anywhere on the circle. On the circle. Put a point C somewhere on the circle. From point C, draw me a chord where the other endpoint is called A. So from point C right now, draw me a chord where the other endpoint is A. Good work, good work. Draw the chord in, just don't put point A. Let's draw the chord in. Also from point C again, so start from point C, draw me another chord where the other endpoint now is B. It's got to come from C still. So from C, you should have two chords drawn. One going to A, one going to B. Okay. Can we all agree that this is not a central angle that you formed? Because point C should be where? If it's a central angle, point C should be the center of the circle, which it's not. Notice where it is, it's on the circle. So if it's on the circle, we call this one an inscribed angle. Okay, that's the one I'm going to introduce to you today, an inscribed angle. Don't put this on yours. That's not inscribed. Even though the vertex is on the circle. Anybody want to guess why it's not inscribed? Ryan?
Because that line doesn't make a point on the circle.
It's got to be two chords. Okay? It's got to be two chords in an inscribed angle. Point has to be on the circle. The other side, the sides have to be chords. All good. I forgot who I asked. I think Alicia answered it. She said that the arc measure was 70 because the central angle was 70. That doesn't work for inscribed angles. They're not equal to each other. But they do have a rule. They are not equal to each other. But here's how you find an inscribed angle. I'll write this down, measure of its arc. But I'm going to add to it. This is the rule for a central angle, right? That's central angle. That's what we wrote yesterday. Now for inscribed, got to take half the arc now, guys. All right, got to take half the arc. So just to make sure before we hit up some problems here, Nihal, big job for you. Give me an arc measure for AB. Arc AB is how many degrees? 70, sure. So if that's 70, what's my inscribed angle going to be then? 35. See how it works? All right, 35. Let's see if I can catch you before I go on to the problems. And you don't need to write this down. All right, Neil gave me that arc was 70 degrees. What's that angle measure then? Okay, everyone see it? Because that's a central. See the difference now between yesterday and today. The central angle is equal to it. Inscribed is half it. All good? Okay, let's do this. All right, I put a triangle inside, called it inscribed. When I do that, help me with these values. All right, find arc BC. Arc BC. I'm not going to ask. I just have a couple questions. I don't need the answer. Sage, going over to you. What type of angle is angle A, the 80 degrees? That's it?
Inscribed.
Inscribed. It's not central, it's inscribed. So you know it's equal to half of whatever the arc was. All right? 80 is equal to whatever half of whatever the arc was. So what do you want me to do with the 80 to find the arc now? What should I do with 80? Nihal to find the arc. Great job. Times 2. All right. If you're finding the angle, you cut it in half. But now I'm going backwards and I'm finding the arc. Multiply it by 2, 160. My recommendation, because going forward, we're going to be doing a lot of problems that have multi-parts, A, B, C, D, who knows how many letters. After you find an answer, label your diagram with it, because chances are pretty high you're going to need it later in the problem. All right, let's keep trucking. Angle B. Let me talk to somebody here. Angle B. Lillian, what type of angle is angle B?
Inscribed.
So I just showed you the rule is half of, what's its arc measure it's drawn to? Half of which arc am I going to take half of?
Angle ABC.
There's it. I'm finding ABC, angle B. What arc is it drawn to? How many degrees in the arc that I just drew that angle to? Ready? drawn to here to here. What's the arc measure that it's drawn to?
88.
88. Are we good? Yeah, no? Okay, good talk. 88. All set? Angle C now. Angle C. Now look. Hey, don't make it more complicated for yourself. You don't have to use a circle fact every time. We've done, I don't know, 9, 10, 11, 12, 1, 2, 7 months now of geometry. Use it. Use it. You don't always have to use a circle fact. And I say that for angle C. All right, Colin, how can you find angle C? Yeah. Yeah, I don't need a circle fact. I know there's 180 degrees in all triangles. Let's see, that's 144, 56. And finally, how about arc AB? 2 ways you could do this. You tell me what's easiest for you. How you want to find arc AB? How many degrees in there? All right, Lillian, back to you. How do we want to find that?
56 times 2.
There you go. I could double 56. Or again, I think Callie asked it for homework. I got 3 arcs. What do they all add up to? 360. I got 2 of them already. Subtract it from 360. Either way. All right, good work, kids. Good work. How do we feel comfortable with an inscribed angle? Because now I'm going to feed you a couple facts about inscribed angles, other than it's half its arc. I'll let you guys go ahead. Find angle ADB and ACB. Find those 2 angles for me. ADB and ACB. You should see that they're both inscribed. Good, worked pretty quick there, huh? Shoom. Alicia, what'd you find for ADB?
62.
How about ACB?
62.
Oh, they came out to be the same answer. Huh, that's weird. Yeah, 62. You guys just found the next fact about inscribed angles. How many did I ask you to find? You ready? 2, and they're inscribed. They have to be. 2 inscribed angles. Other than they both came out to be 62, what else did you notice about them? Where are they drawn to? There you go. 2 inscribed angles drawn to the same arc. And then what was the answer? They're congruent to each other. Yep. Anytime you have 2 angles, they got to be inscribed, drawn to the same arc, they're always going to be congruent. Yep. You guys are off to number 3 now on your own. Go ahead. Take your time. Might be a couple traps here, but take your time. See if you can use this fact we just wrote down. First job, hopefully everyone's finding X to be 5. There's a third of your job done. plug it into either angle because it's going to come out to be the same. Plug it into that one. So that angle is 56. So it looks like both those angles came out to be 56, but I'm looking for the arc though. The arc that they're both drawn to. And they're not, it's not 56 degrees because that's not a central angle. Let me know. Shoom, Bella, how do you figure out what the arc is?
56 times 2.
Got to double it. Yep. Perfect. Two inscribed angles drawn to the same arc, always congruent. All right, next fact. Here we go. Find x, y, and then the measure of arc BC. So let's do x first. Quick question before we do, Nihal. What type of angle is angle x? Everyone definitely inscribed. So once you identify it's inscribed, now your mind goes, I am going to take a half of whatever arc it's drawn to. But unfortunately this time, I didn't put a degree measure on that arc that it's drawn to. Does everyone first see the arc that it's drawn to? From A to B? This is the arc angle X is drawn to. You know that angle? You know that arc measure? Take it, cut it in half. It's not labeled though for me. It doesn't need to be labeled. It doesn't. It says up here in the directions, that's a diameter. Cuts the circle into two equal parts. Yesterday, what did we call this type of arc then? Semicircle. And we wrote down how many degrees? How many degrees in a semicircle?
180.
180. I don't need to tell you that's 180 or write it down. You see that's a diameter, so that's got to be half a circle, which is always 180. So angle X actually ended up being a right angle. Yeah. A right angle. Yep. And we'll get back to that when we're done with the problem. But for now, let's go on to angle Y. Don't overcomplicate it. I know it's inscribed, but you guys don't know the arc across from it. And you won't find it. So you might have to get to angle Y another way. How can I get to angle Y here? Ooh, Ashley?
Subtract from 180.
You got it. Guys, there's three angles and I know two of them. 32. And then the final question is, all right, how about the measure of arc BC? Not the length again, but just the measure. How many degrees in arc BC? I just want to know how you got to it, not necessarily the answer. How do you get to that? Deep breath. Jacob, how do you get to that?
Multiply 32 by 2.
Yeah. Take its inscribed angle and double it. 64. All good. All right, let me introduce you to two more facts before we end class about inscribed angles. We already discovered the first one. Here was the first one. Actually, no, I don't need to, but you'll be on deck there, big dog. You got me. You're on deck next time. Who answered this for me? Who answered what type of angle was X? Who did that? Neil, was that you? Yeah, it was. It was. I asked Nihal what type of angle was X at the beginning, and she said inscribed. Right? She said inscribed. And then I took over and said, hey, where's it drawn to? And there was a little bit of silence, but we ended up figuring out if that's a diameter, it was drawn to what type of arc? Yep. Well, we have a name for it. A semicircle. All right? So anytime you have an inscribed angle drawn to a semicircle, it's always going to be what type of angle? A right angle. All right, that's what this first theorem here says. We don't need to draw a diagram because we already have it up here. Everyone see it? Inscribed, if it's ever drawn to a semicircle, it's always a right angle, always. All good? And then the final one here, you guys are going to create. I didn't give you much room, I apologize. Right next to the second theorem, can you draw me a little circle there? All right, I'm going to use some vocab for what I need next. I need a quadrilateral inscribed in that circle. a quadrilateral inscribed. Where's the quadrilateral going? Inside, just floating inside? The vertices touch. We know our vocab. Good. And call that quadrilateral ABCD because we're all creative in here. ABCD. I better make them touch and follow my rules, huh? All right, here's what it says. If you have this, a quadrilateral inside the circle that's touching, the vertices are all touching the circle, opposite angles, supplementary. That's a word we haven't used in a while. What's that mean again? They add to 180 degrees. So give me two angles in our diagram that add to 180 then. Give me two angles that have to be supplementary. Add to 180. You want to take this image in angles? Opposite angles. I just need the names of them. I don't need a degree measure or anything.
D and B.
D and B, yeah. So if you take the measure of angle D and add it to the measure of angle B, we are guaranteed by this fact that they're going to equal 180. And the same thing if we wrote A and C. I don't know what the degree measure is, but I know they add to 180. All right, why don't you finish this off right? Go ahead and finish this last problem here, parts A and B. Take your time. Think about all the facts I gave you today about inscribed angles. All right, so you guys can get to the assignment here. How, not what the answer was. How did you find part A? Arc G to F to E. How did we find that part there? Bella, how'd you find that?
86 times 2.
Good. Inscribed, 86 inscribed, and it's drawn to that arc I'm asking for. So make sure if you need to find the arc, you double that bad boy, 172. And then how'd you find angle F now? Angle F, let's Bella finish it off.
180 minus 86.
Opposite angles in a quadrilateral are supplementary as long as it's inscribed. Yep. And what did we get there? 94. Yeah, 94. All right. Okay, go ahead, tackle the homework. So we'll have 15 minutes.